How dangerous is radiation for human Mars missions? Imagine traveling millions of miles from Earth, heading toward a planet with no protective magnetic shield like ours. It sounds exciting, but the real challenge is what you can't see: radiation. When astronauts go on Mars missions, they face a serious health risk from ionizing radiation. This radiation comes mainly from two sources: galactic cosmic rays and solar particle events. Galactic cosmic rays are high-energy particles from outside our solar system, and solar particle events are bursts of energetic particles from the sun. Both can penetrate spacecraft walls and human tissue, causing damage at the cellular level. Unlike Earth, which has a magnetic field and thick atmosphere that block most radiation, Mars has very little protection. This means astronauts are exposed to much higher levels of radiation during transit and on the surface. The radiation dose for a typical Mars mission, which lasts about 1,000 days including travel and surface stay, can significantly increase the risk of health problems. Studies estimate that this increased exposure could raise an astronaut's lifetime cancer risk by about 33%, pushing it from around 15% to 20%. That is a big jump and a major concern for space agencies planning future missions. The risk of immediate radiation sickness from solar particle events is low but not impossible. Spacecraft shielding can block some of the radiation, especially from solar events, but it only reduces galactic cosmic ray exposure by about 7 to 15%. Astronauts on the International Space Station, which orbits Earth, receive about half to 1 millisievert of radiation each day. In contrast, measurements from Mars missions show a dose equivalent of about 1.80 for millisieverts per day in deep space and about 0.64 millisieverts per day on Mars itself. Over the entire mission, this adds up to a total dose much higher than what astronauts experience in low Earth orbit. To combat these risks, space agencies are working on multiple strategies. Astronauts undergo training to understand radiation risks and learn how to minimize exposure. Mission planners try to schedule trips during periods of low solar activity when possible. Researchers are also exploring biological countermeasures, like drugs that protect cells from radiation damage, and even genetic approaches in the future. On Mars, habitats could be built with several meters of packed soil or other materials to provide extra shielding, especially since astronauts will spend a lot of time both inside and outside their living spaces. Looking at past space missions, astronauts who have spent long periods in space have received radiation doses similar to or higher than what is expected on Mars. Interestingly, they have not shown immediate health effects, but scientists are still concerned about long-term risks. The bottom line is that radiation remains one of the biggest hazards for human Mars missions. It demands careful planning, advanced shielding, and ongoing research to keep astronauts safe during their journey and long after they return home.